Okay, let's look at the last little bit here in A.2, which is finding zeros of a function. Remember we said we're finding the zeros of our function are essentially where our graph hits the x-axis here. Okay, let me label my axes. And in this case, x represents time. So, for example, they gave us this problem of a falling object that's dropped from initial height. An egg is dropped from a height of 64 feet. How much time elapses until it hits the ground? Okay, well, it's going to hit the ground here at this point. Well, that's what's called a zero of the function. And that's essentially the x-axis is where y equals 0. So I'm going to plug in 0 for f of t, which is essentially our y. And then I'm going to go ahead and solve this. And the best way to solve it is using those factoring skills we learned in the last chapter, chapter 7. And of course, we could solve it a couple different ways, but I'd prefer you to use factoring when in doubt. So if I were to factor something out of both of these terms, a greatest common factor, a GCF, what's the largest value that divides out of both of them? Well, you'd be correct if you said negative 16. Okay? And remember, that negative 16 is just going to come out front. It's that process of factoring we worked last chapter on. Well, negative 16 over negative 16 is 1. Leaves me just t squared. And 64 over negative 16 is minus 4. As you recall from our previous chapter, we looked at then factoring this even further. And we said, oh, that's t and t. And then what two values multiply to 4? Well, 2 and minus 2. And if I did my cross multiply check, 2t minus 2t is 0t. Notice I have no bx term there, so that makes sense. Okay, so my factors then are t plus 2. Remember, then we read them horizontally. And t minus 2. Okay. And remember, in situations like this where we had it equal to 0, then we could set our two factors equal to 0. Of course, any constant out front like that minus 16 we divide out. So 0 equals t plus 2 and t minus 2. Then I'm going to set both of those factors equal to 0 and solve. So t equals minus 2 and t equals positive 2. Those are what's called my zeros. Okay. All right, so I know that at a time of 2 seconds here, that our egg is going to hit the ground. Okay. And of course, if say this were a parabola, it came back here more to there. Then this would be here at negative 2. But of course, we don't have that. This is just an egg. There's only the positive time component. We can't have that, so we don't really worry about that one. Okay, but so what did I do? Well, I set y to 0, and then I factored and I solved for, say, my zeros. And I prefer you to use factoring in this section to practice those skills that you used in the last section. Okay, so let me do one more. Maybe I had f of x equals negative x squared plus 25. Okay, so again, I make y be 0. And then I say, what can I factor out of both of those terms? Well, just that -1. Remember, we said if we ever have a negative out front, let's factor it out of our ax squared term. That leaves me with x squared, the negatives cancel, and minus 25. And then I say, oh, I can factor that farther. X and x, draw my magic x, 5 and -5. I do my cross multiply check, and I notice I have no bx term. Well, that makes sense. I don't have any bx term. It would be right there, right? But it's not. Okay, so then I know my factors are x plus 5 and x minus 5. So 0 equals x plus 5, x minus 5. Remember, then read your factors horizontally. Okay, then set each individual factor equal to 0 and solve. X equals 5 and x equals -5, and those are what's called my zeros. The zeros of the function. Okay, in other words, where y is 0 is where it hits the x-axis. So the location that it hits the x-axis. Okay, so these should be enough to get you going and finish through section 8.2. Thank you.